This is the first of several worked examples that we'll do on solubility product constants. And solubility product constants are just different examples of the equilibrium problems that we've already been doing. So we want to know the molar solubility of lead-2 chloride in pure water. So we want to know how much lead-2 chloride will dissolve in water. And to solve this, I need to do an ice table. So I need to write the reaction for the dissolution of lead-2 chloride. So lead-2 chloride, the formula is, of course, PbCl2. And when ionic compounds dissolve in water, they dissociate. So I'll get Pb2 plus aqueous and 2Cl minus aqueous. And so the molar solubility, to get this, I just need to do an ice table, and the molar solubility is the change. And in previous examples of equilibrium problems, we've called the change x or 2x or minus x. And in these KSP problems, we just change that to S to remind ourselves that the change is the molar solubility. So when I build my ice table, of course, lead-2 chloride is a solid, so it does not appear in my equilibrium constant expression. So I don't have to worry about it in my ice table. I'm dissolving this in pure water, so the initial concentrations of lead and chloride are 0. And then the change, so I have a coefficient of 1 in front of the lead, and so it will be plus S. And then that makes the chloride plus 2S. And so this is, S is the molar solubility. So this is what I'm solving for. And so then, of course, at equilibrium, 0 plus 2S is just S. I'm sorry, 0 plus S is S. 0 plus 2S is 2S. So now I just need to plug this into my expression for the equilibrium constant. So KSP is equal to the concentration of lead 2 plus times the concentration of chloride squared. And so I can go ahead and plug in my numerical value for the KSP, 1.17 times 10 to the minus 5, and then plug in the values from the equilibrium row of my table. So for the lead, I just have S. For the chloride, I have 2S, still squared. All right, and so we have a little bit more room. Let's go ahead and finish solving this on the next slide. Okay, I've rewritten the last thing that I've written here. I've got the equilibrium constant and the equilibrium values on the right-hand side. So to solve this out, 1.17 times 10 to the minus 5 is going to be S. When I square this guy, I have to square everything that's inside. So when I square the 2, I get a 4. When I square the S, I get an S squared. So now when I collect terms, I'm going to have 4S cubed. So then I'll divide both sides by 4, and I get 2.93 times 10 to the minus 6 is equal to S cubed. So to get rid of a cube, I need to take the cube root, or I need to raise both sides to the 1/3 power. So that's how you do it on your calculator. You'll take this number, raise it to the 1/3 power. And so that gives us S is equal to 0.0143 mol, and then the units when we're doing equilibrium problems are always molarity or moles per liter. So the molar solubility of lead-2 chloride is 0.0143 moles per liter. That means I can dissolve 0.0143 moles of lead-2 chloride in 1 liter of water.